Okay, YouTube, briefly in this video I want to go through how we graph horizontal and vertical lines and then kind of indicate what's true about their equations every time. So we're going to start with this example right here. It says graph y equals 3 in the rectangular coordinate system. And as a hint here, I indicate that you should make a table of values to support your findings. So when we say y equals 3, the interesting thing is that we've been discussing slope-intercept form. And the thing here is I've got some equation that says y equals 3. So now I notice that there's no x value whatsoever. So one thing that I kind of want to point out before we begin is this: because there's no x value, this would indicate that we actually have a slope of 0 on our graph, and that we must have some line that looks like this. So it does have a y-intercept of 3. I could proceed up to there right now, and I could say that this point right here is the point 0, 3, being sure to label our points. And with a slope of 0, what this would indicate is that we have a line that's neither rising from left to right nor falling from left to right, but that we have some horizontal line. So when I say let's make a table of values to kind of back up our statement here, what I want you to see is that if we were to use, like, say, -2, -1, 0, 1, and 2, then what we're going to do is we're going to say, well, plugging in -2 into this function, because we have no x value here, the moment you plug in -2 for none of these x's that don't exist here, okay, you just get 3. And we would also get 3 here, and 3 here, and 3 here, and 3 here. These would essentially be all of the points on the graph, because if we were to substitute all these point values back into the original equation here, all of these would be substituting in a 3 on the left side of this, and we would get a true statement 3 equals 3. So what I want you to know is that whenever you have a line that is, is given by the equation y equals a constant, then basically what we can say is that line right there is some horizontal line, okay? Likewise, when we look at graphing an equation like x equals -3, this is an interesting equation here. As a matter of fact, this cannot be written in slope-intercept form, but I do want to point out that the only points that we're ever able to plug into this must have an x value of -3 to make the original statement true. So this could be 1, 2, 3, 4, 5. Essentially, if I go graph all these, it'd be left 3. I guess we could go -3, 0, -3, 1, -3, 2, 3, 3, 3, 4, 3, 5. These were all these and I indicated here. But basically what we're going to get is a vertical line. So what I can tell you is whenever you get an equation that says x equals a constant, you must be dealing with a vertical line. And I should be labeling both of these. So this is x equals -3, and then this is the line y equals +3 over here. So really quickly what I want to do is kind of recap what we've just mentioned, but we say that a horizontal line is always given by the equation y equals b, where b is some real number here, okay? So we would say that a horizontal line, it's important to note here that we're using b in this particular example because b would still be the y-intercept of this line, and we could see that this b existed right here as well, but that we have a slope of 0 on this line. And a vertical line is always given by the equation in the form x equals a, where a is some constant. We could say that a is the x-intercept of this line, just like b was the y-intercept over here. But that it passes through all the points having an x value of a, and it's a vertical line. Cheers.